All right, so now let's look at the definition of continuity. So a function is continuous at a point, c, if the limit, as x approaches c of f of x, is equal to the value of the function at c. So like in example 1, we saw f of x was equal to x squared, right? And we saw that the limit as x approaches 2 of x squared is equal to 4. And we saw that f of 2 is equal to 4, right? So we can say that the function f of x equals x squared is continuous at 4, right? Because if we approach it from either the left or the right, and get closer and closer to 2, the value of the function gets closer and closer to 4, and the actual value of the function is 4. All right, so we can say that the value of the function is continuous at x equals 2. All right, so that's the definition of continuity at a point. All right, and the other definition that's here, kind of in one box, these are actually two definitions, is the definition of a function being continuous over an interval. So a function is continuous on an interval if it's continuous at every point in that interval. All right, so let's take a look at a few functions, and let's first of all just focus in on the definition of continuity at a point. So in example 4, we're looking at we're going to look at the continuity of these functions at x equals 2. So let me scroll down so you can see the whole thing. Let me see. All right, that's good enough. All right, so what we're going to do, we're going to look at what happens to f of x as x approaches 2 from the left, 2 from the right. If they match, then we have a limit at 2. And then we're also going to look at the value of the function at 2. All right. So for this example, this actually looks like x squared, right? So this is f of x equals x squared. And if I approach 2 from the left, it looks like it's approaching 4. If I approach 2 from the right, it looks like it's approaching 4. Because those limits match, then the limit as x approaches 2 is 4. Now, I can plug 2 right into the function, right? And I get 4, right? That's what the graph is telling me. Now, I happen to know this is just x squared, but just from the graph, I can see that the value of the function is defined to be 4 when x is equal to 2. So the value of the function is 4. So now we have the limit is equal to 4. The limit as x approaches 2. Let me see if I can scroll down just a hair more. Without, okay. Let's see. Just a hair more. Okay, that's fine. So the value of the function is 4, and the limit as x approaches 2 from either side is 4. So I can say, yes, this function is continuous at 2. And the reason is that the limit as x approaches 2 of f of x is equal to f of 2. Okay, so it's continuous at 2. All right, so let's take a look at g of x. So again, if I approach 2 from the left, it looks like the value of the function is approaching 4. If I approach from the right, it looks like the value of the function is approaching 4. So those two limits match, and I can say that the limit as x approaches 2 is 4. All right. Now, this is a little different because now I have an open circle at x equals 2, right? So the value of, even though that point is shown to be 2 comma 4, right? The value of the function is actually undefined. Undefined at x equals 2, all right? Because that's what the open circle is indicating. So in this case, the limit does not match the value of the function, right? The function is undefined at x equals 2. So I would say no, it is not continuous at x equals 2 because the limit as x approaches 2 of f of x or no, it's not f of x, it's g of x, sorry. Let me back up. G of x does not equal g of 2. All right, g of 2 is undefined, even though the limit exists. All right, let's look at this last one. We have a piecewise function that has a break at 2. So let's look at what happens as we approach from the left. The limit as x approaches 2 from the left of this h of x function looks like it's approaching 4, right? Now if we come at it from the right, it looks like it's approaching 2, right? So this limit does not exist. I'm just going to write dne. And what is the value of the function at 2? Well, I have a closed circle at 2, 1. So it looks like the value of the function is defined to be 1 when x is equal to 2. All right, we have an open circle at 2, 4. So that would not be the value of the function. The value of the function is 1. All right, so but again, the limit doesn't exist, right? The limit as x approaches 2 doesn't exist, even though the value of the function exists. And so the function is not continuous at 2. And again, the reason is because the limit as x approaches 2 of h of x, which doesn't exist, right? Because I'm getting different limits when I approach it from the left or the right. This is not equal to the value of the function at 2. All right, so that's the idea of continuity at a point. And in the next example, we'll take a look at the idea of continuity over an interval.